Good morning. So, year 10 today, what we're going to be doing is we're going to be looking at conservation of energy and how energy is dissipated, and that's a really important word. Dissipation of energy is where it is transferred from one form to another. So that's what we're going to look at in today's lesson. So, make sure you've got pen, paper, you've got yourself ready to learn, and remember, if you need to, you can stop the video at any time so that you can complete the tasks. Okay, here we go. Okay, so the first things we need to know then is the law of conservation of energy. So energy can neither be created nor destroyed. It can only be transformed from one type to another. That means that the total energy remains constant. So all the energy that is on this planet is a constant transfer of energy. It means it's a closed system, okay? So the energy at the start is equal to the energy at the end, or the before and after. So it's transferred and usually stored or dissipated into a place. So when we talk about a closed and open system, what we're saying is that the energy comes in and the energy that goes out, okay, there's no transfer of mass, there's no change in that, it's closed. Because in an open system, the energy that goes in and the energy that goes out, there's also a change in mass. So we must understand that this is a closed system. Okay, so in lesson 1 we talked about this idea of types of energy and different types and how they can transfer from one type to another. So I want you to think about your energy transfers, remind yourself of that lesson. I want you to make a flowchart of the energies involved during the takeoff and flight of a plane. Think about how it's a closed system. Try and explain that in your answer, okay? So if you want to, you can film your answer. You could do a little PowerPoint poster, whatever you want, okay, of your answer. But make sure you've got that. And on the next slide, I'm going to talk to you about how that should look. Okay, so hopefully you've managed to identify that as the aeroplane takes off, the speed increases. So the chemical energy stored in the plane is converted to that kinetic energy that allows the plane to move. As the aeroplane goes higher, the kinetic energy is transferred to the gravitational potential. And then while flying, some of the energy is dissipated through drag to thermal energy and sound energy. So ultimately we have certain energies there that are being dissipated, which is why some of the energy that is chemical is transferred to kinetic, and by the end of the flight that kinetic energy is going to be dissipated to heat and sound, as that is a type of wasted energy. So your task for this lesson is to take into consideration all you've done in the other lessons. I want you to think about how objects move and how devices such as mobile phones continue to work. How can you calculate energy stored in objects? So how would you know how much battery power you have? Or how do you know that a can of sugary drink, how much chemical energy there was? You need to be able to transfer that energy, and you need to understand that it all comes from the sun. So how would a solar panel work? So the importance here is to relate the idea of efficiency to how it works. So this is a web quest, okay, and by the end of this you should be able to describe the changes in energy stores when a system changes, and calculate the energy stores of various objects and calculate the efficiency, okay. You've probably heard the efficiency mentioned a million times now in the other lessons. So how, Mrs. Haughney, you're asking me, am I going to be able to do this? Well, you're going to put it into steps, my dears. So you're going to look at the various systems, okay, you're going to look at a store. So how many AA batteries would a car need to travel a certain distance? How many cans of sugary fizzy drink would you need to climb Mount Everest? What areas of solar panel would a UK household need to provide its power? So when you've got this, you're going to show your answers in some sort of PowerPoint presentation. And here are the steps for you to be able to do that. So step 1, you're going to research the amount of energy stored in an AA battery. You're going to research the amount of energy needed to drive a car 1 kilometre. You're going to use your findings to calculate how many batteries would need to travel 1 kilometre. Okay, so have a look at calculations for that. I've got some websites coming up on the next slide. Step 2, you're going to research how much energy is stored in a typical 330 millilitre can of a sugary drink of your choice. You're going to research the height of Mount Everest, and you're going to make a calculation of gravitational potential energy. Okay, you're going to use your findings to calculate how many cans then of sugary drink you would need. And for step 3, the solar panels, you're going to research how much energy comes from the sunlight and falls onto 1 metre squared in a year in the UK. You're going to research how much electricity a typical household uses, and you're going to look at solar panels and at how efficient, okay, they're 100% efficient, but would you be able to calculate the area of the solar panels? You need to remember devices waste some energy because some of it is dissipated always normally into heat. Okay, so they're not 100% efficient, so you need to find out the typical efficiency of those solar panels and calculate the area. And then step 4, all you're going to do is split that information onto a PowerPoint, and ultimately, if there's anything, okay, for example, that you find surprising or anything that you found interesting, pop that on there as well for me. Okay guys, so for the task, here are some ideas that you might want to try looking up. So if you go into Google, have a look up the energy in joules per an alkaline life battery. You can always go to the Transport, Energy and Admissions Urban Public Transport website and have a look at that. And also there's a life cycle efficiency of transport modes table that you can find. It shows the megajoules per person per kilometre of operating a car, so that will help you. Coca-Cola, you can go to the SDDB website. You can look at the idea of how much is stored in 100 mils. You want to try and find the value in kilojoules. BBC Bite Size, conservation of energy, gravitational potential energy will help you to calculate gravitational potential energy, and also the lessons we've done previously. With the solar panels, you can go to Greenleaf Innovations, find a map of the UK, and it will show you how much kilowatts per hour. There's also a website about home energy sources and how much electricity is being generated. Solar panels, there's a Go Further section in Bite Size for conservation of energy and kinetic energy. Okay. And there's a website called 55 Interesting Facts About Energy. Okay, most of the stuff will help if you place go into Google. Remember, you might have to go into a couple of the websites and have a look through that information to get to all the stuff you will need. Try your best to see how you can get on and see if you can get the task completed. And the final thing we're going to get done today then is I want you to have a light bulb moment. I want you to have a go at using the information you've learned from those last tasks, okay, to tell me what the difference between a normal light bulb and an energy efficient light bulb is. Talking about this idea of energy cannot be created or destroyed. So what is happening in a efficient light bulb that is different from what's happening in a normal light bulb? Okay, so the idea is here that it's very research based, and once you have your research, put it into a little PowerPoint, and then can you send it to me at mhaughney@knoleacademy.org, or Miss Nixon, again K Nixon at knoleacademy.org. We will look at your work as much as we possibly can, get back to you as well, and give you feedback on it. Okay. So the outcomes for this lesson is to identify how energy is usefully transferred, stored, dissipated, but not created or destroyed. You need to be able to describe examples, okay, so that's part of the task that we set you to do, and you need to know that there is no set energy change as such because energy is being transferred. You should also be able to describe how the system changes energy and then how it is dissipated, how it is stored in useful ways, and how it's described as being wasted when it's dissipated in non-useful ways. Hopefully this lesson is going to be a bit of a challenge for you, and I look forward to seeing some of the work. Well done guys, carry on keeping up. You're working extremely hard. Keep going.